Hello, everyone. My name is Matthias Kirst. I'm the founder and CEO of Biomine. That's a spin-off of SoloCell. I was also the co-founder and former CEO of Rapid Genomics. This is a company that I created in 2013 and was acquired by the LGC Group from the UK in 2022. I work as the UF Entrepreneur in Residence, and I'm also a distinguished professor at that university. In that role, my job is to create plans that can support the US transition to clean energy. Now, the US right now has 34 battery factories that are planned in construction or operational. In 2019, we had 2. There's been over $100 billion that have been invested in these factories, and they require a lot of nickel. One Tesla Model 3 requires 60 kilograms or over 100 pounds of nickel. And very soon, for you to be able to qualify for the US tax credits, over 80% of the material in that battery will have to be sourced from the US. The problem is the US produces almost no nickel. The US produces about 17,000 tons, which is less than 15% of what it needs. Indonesia mines about half of the nickel in the world. China and Russia process about 45% of the nickel that's used in the world. In the meantime, US can mine less than 0.5% of all the nickel that is consumed. What's the mission of Biomine? Is to create a plant-based mining so that we can have sustainable, reliable sources of high-quality nickel and other high-value minerals to support the US transition to clean energy. Our goal is to launch it in the spring of 25. We are at the pre-seed stage seeking $1.2 million, and it is based on a licensed UF technology that was developed in my laboratory at the university. So how can Biomine do that? The US has 2.3 million hectares of low-value nickel-contaminated soils. These soils aren't good for agriculture, and nickel concentration is too low for standard mining. Now, nickel could be mined from these areas by what we call phytomining. This is the planting and harvesting of plants that capture and store nickel from the soil. Now, plants usually don't do that. Nickel is actually, in fact, toxic for them. Now, what we have done is that we modified plants so that they can hyperaccumulate nickel using a novel combination of genes that we discovered and that we have patented at the University of Florida. Using those plants, we could generate up to over 0.5 ton of nickel per hectare per year. Now, the advantages of using these methods include the fact that plants could be harvested using standard methods that are used in agriculture and forestry. We wouldn't need any new type of equipment, any new procedure. There's a very low cost of production because we are not mining this nickel from the soil. There's an ultra low cost of processing compared to traditional processing of nickel materials because we recover nickel from ash, not extracted from rock. Significant advantages for national security because that would allow us to create a consistent and reliable source of nickel in the US. And there are a number of additional high value added products. We could generate carbon credits, biomass, cellulose, timber, and bioenergy as byproducts of this process. What's the size of the market? $40 billion is the global market size. $2 billion is the size of the market in US, and it's growing significantly. Of that, 57% is entirely dependent on imports, and that's the market that we are targeting, $1.2 billion. Thank you.